Hi, everybody. I will be talking to you guys about going from sketch to code and designing a component kit. So what we're going to be talking about today is why are we talking about components, what makes a component, what a component kit is necessary, how designers in Storybook.js contributes to the design overall, and how we put it all together. So as most speakers do, we introduce ourselves. So I'm Samantha. I am a software engineer at Major League Soccer. We just finished launching a React Native app using React Native Web, where we are blending the gap between mobile and web. I also like to build small furniture. Here you can see in my apartment, I have a 12-foot-long desk tabletop, and I also play flag football. Here's my flag football team. We won second place. I was very proud. Thank you. So why are we talking about components? The idea of creating a shared library of components is kind of something everybody understands. It's an easy concept. But the difficulty is deciding which components to create. So first thing is technology is changing, and we should too. Copying and pasting is old school, and it's not scalable. When one team builds a component and another team builds the same exact component, it's a lot of work and a lot of wasted time. There are so many more devices and so many more ways to access information. We need to also worry about those. So for those people who think like technology is changing so fast, and I know you're out there, by the time you build all your components, the new tech will come out. And they're right. That actually is true. But let's take advantage of the technologies that we have now and not worry about those until they come out later. So next thing about why we're talking about components, because there is less work and less code. It's pretty self-explanatory. That's why we use the components. Which brings me to my next point. Managing projects become more efficient. Our code base gets reduced by a lot. Our actual files get a lot smaller. And when updates need to happen at the component level, it will happen across app. Yeah. So there's no more guessing if the component is causing the problem, because we're going to be able to isolate those bugs. So your component will need to be very well tested, and we will talk about that a little bit later, but we can eliminate the component being the problem. So honestly, that bug is a you problem, not a me problem. So I'll be a little straightforward. There's a lot of component libraries out there already, so why do we want to build our own? Well, it's simple. It's because of branding. So the lead engineer from Airbnb quoted that software is often built by incredibly large teams of people. The challenge to create coherent experiences multiplies exponentially as more people are added to the mix. Over time, no matter how consistent or small your team is, different people will contribute new solutions and styles, causing experiences to diverge. So the more inconsistent the user experience is, slower production development becomes, and vice versa. So we want to make sure that we create a consistent user experience across multiple apps and multiple platforms. So what makes a component? Well, it needs to be reusable. It allows you to easily create new components from existing ones. It needs to be composable. You can combine it with other components to make new experiences. And it needs to be encapsulated. So like isolated markup, isolated styles, and isolated behavior. So that's a textbook definition of what a component is. But after working with them for quite some time, I have come up with some other tips and tricks that we can use. So components need to be static. They're like your application's primitives. The only task that components should have is to render data. By whatever means necessary, let's not fetch your own data. Let the app do that for you. And if you have similar components, make sure you have a similar API. As you see here, the card on the right, and there's a list item on the left. These two components were built by two different developers, and which would make us have different prop naming conventions. And the card on the right was an image prop, and the list item on the left was an image URL prop. And that was really confusing, and it made memorizing the API really, really hard. So you need to have somebody who kind of is in control of naming conventions. Then we need to be able to overwrite the styles. And dealing with iOS and Android, sometimes they don't play nice together. They're like Sour Patch Kids. Sometimes they're sweet, sometimes they're sour. It's not good. So adding margin or height on one would work, but then on the other one, it just wouldn't. So we need a way to handle those bad kids, right? And it can be really hard to override those styles that are embedded, but allowing the app to control the bounding box of a component is a great start. And then we need to make sure that the components are discoverable. If we can't find it, people aren't going to use it. So we need to have a complete list of each component and all their prop types listed out. Then we need to talk about overexposing. When we first began building our app, the app would decide what state to render. The app would expose a card tile and a node tile from the API. So we decided to then put the weight of the state on the component itself versus the app. And it created a lot less boiler code. The next thing I would say is to treat your components like a third-party library, as if you're going to open source it. Generally, when something is open source, it's well-tested, well-maintained, versioned, and well-tested. And well-documented, sorry. And the last thing I would say is that you don't have to make everything a component, and try to limit as many as you can, because forcing everything a component makes it a lot harder to maintain. And if you're only going to use it 1 or 2 times, I would recommend not making it part of your library. So this brings me to my next tip is how do you know something is a component? So I made a little checklist. So if you can easily change or modify it, then it's probably the same component. But if it requires a lot of changes, then you probably need to make a new component. What it looks like and the purpose of the component can help determine if it's something needs to be new or an extension of existing. So you need to ask yourself, if I change appearance of X on component A, do we expect X should also change for component B or C? If so, you might have the same component. Again, we have to figure out how often a component is going to be used. So if it's a one-off because of the design, it's probably not a component. And you need to make sure you give components abstract names. Avoid naming conventions that are so specific, like a snippet rather than a search results snippet. Ba-ba-ba! We're going to play a little game, all right? So I don't have a demo, so I'm going to waste some little time with this little game. So I can't really see everybody's faces, so the front row, it's up to you guys to tell me. You need to do a little bit of this, a little bit of that, okay? So we're going to play, is it a component or nah? So, is this a component? We have a button, but look at the code. Front row, what do you guys think? Nah? Right, it is not a component. Why? Because we cannot override the styles. So for me, in my opinion, it's kind of useless to have this button, because if I can't move it around my app, then I don't want it. We can put a view around it, but then there's an extra view. So, Okay, a button again. Let's try it. Is this a component or nah? Look at the code again. Nah, okay, cool, yeah, because it's fetching its own data, and since it'll be kind of useless because the API might change in the future from like maybe a RESTful to maybe a GraphQL. So, nah. Is this a component or nah? So, design doesn't really like component A on the right and wants to change it to component B on the left. Is this the same component? It's a little trickier. Okay, I said yes, because we're able to easily modify the changes, and we don't have to really mess up the data that's coming in. So, yay, we have a component. So why is a component kit necessary? Well, the first thing is because it's organization. People need to be able to see what components are available. Developers should be able to browse the kit in a meaningful manner, identify the components, and the hierarchy within which they live, sorry. By approaching product, and then we have communication. By approaching the product development like Lego blocks, we get more time back in our day to focus on more, bigger problems. And we reduce the amount of redundant conversations for one-off solutions. So, and it also allows us to have faster development. Reusable components help your team move faster by creating high-level abstractions. Components eliminate decision fatigue by enforcing a standard approach. For example, here's the card component. We no longer have to each time make a card. We don't have to think about should the date go above or below, should we have padding left or right. Those little tiny decisions will add up, but if we have a component, we don't have to worry so much about that each time. And lastly is performance. Having components minimize the application's bundle size. Using the component a second time doesn't require additional download. And without a component kit, you're more likely to duplicate JavaScript that solves the same problem in similar ways. Even worse, developers are likely to grab another competing library and thus requiring users to download multiple full libraries to do the same exact thing. So how do you start building a kit? Well, there's two paths to product first and tech first. We're only going to be doing product first component kit. So the first thing you need to do is create a design system. This is technically the same, not technically the same as a style guide or a pattern library, but it's pretty close. Building and maintaining a design system is definitely a big challenge for us, but overall it's one worth facing. It can help break up your team out of a vicious cycle of unscalable design. The design system is truly a gold standard, but it's not set in stone. It should evolve with the product and always reflect the truth. That way, we don't have user confusion, like different patterns responsible for the same actions kind of confuse the users. We don't have slow design process because the designers are not building everything from scratch. And we have a better time onboarding people since we can introduce designers and developers to like a documented system. On this slide, you'll see different things that we can include in your design system, like color palettes, design principles, and icons. So once you have a design system, we need to make sure we're able to hand off the designs to the engineers. And I have determined some requirements in order to choose the right tool for your team. So with a handoff tool, you need to be able to create easily shareable outputs. That way the engineers can create their own assets and not have to wait for the designers to give them to them. We need to be able to generate and display specs in the design tool. And we need to be able to sync specs when designs are updated. We consider our design the source of truth, and it can be really challenging when discussions about design are updated somewhere else, like in Jira or in conversation. But you always need to make sure you have a note on your handoff tool about the final decision. And lastly, we need to be able to distinguish between different properties like fonts and colors and parameters. So after looking at all those requirements, we decided to use Zeppelin. It's a tool where the engineers can see design and code. It's great for designers because it has a plugin for Sketch, which allows them to quickly update designs, but it's also perfect for engineers because there is an extension for React Native. There's also a lot of room for communication around Zeppelin since we can add comments to files to add comments to files. And each Zeppelin file has its own link where you can add to Jira. So now that we have a design system, we need to make sure we have a code implementation. That way we can reduce code That way we can reduce code and save time during development. You could think of this as a living style guide. And we decided to choose Storybook, but there's a lot of other options out there like Style Guides, or you could just make your own. But for us, it was a great decision. With Storybook, we were able to do the complete life cycle of a component where we can develop and design, show documentation, have discussions, and solve bugs in one place. So there's a lot of great talks about Storybook, so I won't really go into it, but pretty much you write stories in JS, and then the magic happens. You're able to see your components in different states. Developers can quickly copy and paste into the app, and we are able to document and keep them up to date with a with info add-on. There's a lot of great add-ons you can add, but I also recommend adding real data to your stories. We decided to hook up our GraphQL client to our Storybook. That way, random images weren't being used, and design can visually QA a lot better. So for me, the best thing about Storybook, it allows you to develop in isolation. As you see on the slide, I have an example of a component in the app and a component in Storybook. When you're working in the app, to get to that component, I would have to wait for the app to load. Then I would have to click on scores, the tab at the bottom, and then I have to wait for that to load, and that's a pain. Ugh. But since Storybook is so fast, I can do it in half the time. And my favorite thing about it is it splits up the complexity among the team based on the different skill levels. This is one of my first components I made, but there's a lightning talk after lunch given by Erin, who is going to tell her experience about using Storybook as a junior engineer, and I'm looking forward to hearing about that. So how do we put all this together? Well, the first thing I would say is communication. It's the glue, it's the foundation. We need all teams, design, engineering, QA, and product to be on the same page when it comes to components, or it would be a hot mess. The product team needs to make tickets in Jira, and the QA team needs to test the components in isolation. Since we're on the topic of communication, I'm going to do a little quick public service announcement. Everybody's perspective on your team is very important, so please allow juniors and women to speak. We have tons of ideas, and it's hard to speak over when there's a lot of men talking over you. We have a lot of things to say. Look at me, I'm up here telling my story. So amplify us when we have ideas, good or bad, because it will make the whole team stronger. So back to the public. Thank you. So this is the first step of a component kit. We need to make sure that we have the stakeholders, the product, and design. They need to come together and brainstorm the needs of the users and business goals. I'm not really sure how they communicate during that time period. For me, it kind of looks something like this. And then us engineers are over there just waiting for them to figure that out. But overall, these three parties understand that there's going to be a design system, and they need to create components that are reusable, because they are worried about consistent quality, speed to market, and maintenance. And for the purpose of the rest of this talk, I'm going to be bundling those three teams as design, just to keep things a little bit more consistent. So after all that's said and done, they had this jibbly-jabbly, we come up with a component kit. And here you can see all the different states of the match tile that can be used. At the bottom of Zeppelin, there's a note toggle where we can see all the different comments that people have and all the discussions, and just to make sure that we keep this a source of truth. And yeah, and after that, the engineers get the Zeppelin files. So the communication between designers and engineers. So this is the ideal way. It's called the throw it over the fence method. In this diagram, you can see the designers take a concept from idea and create detailed designs. And then all the things that could go wrong, they figure it out beforehand, and then the engineers come in, pick up the designs with no questions, and build it. Then the design comes back and approves everything and ships it. That is awesome, but we all know that's not real life. Okay. So the more realistic way of working is one team, not two method. The design team still starts the work on their own, but the key difference is they engage the engineering team much earlier. That way they could get earlier tech feedback, and it gives the engineering team earlier exposure to the upcoming work. And for me personally, I love this method. Seeing the work earlier keeps me excited and inspired. Being involved in the process early reaffirms the company's why to me. By having that 30-minute to an hour conversation early on about the future, about what's coming up in the next month, is crucial to the team's culture. Just taking the moment to explain to me why this new feature is important makes me feel like I'm helping you tackle the problem versus just making it for you, and keeps me motivated. And shoot, I could tell the designers early on that this feature is not going to work, and so we can meet those lovely deadlines. But of course, when you talk to designers about problems, you should always keep a good solution as well. So we also have a design system engineering committee. While everybody on your team should understand what goes into the component kit, having a few people on your team to maintain is great. We have a continuous conversation about once a week about what components should live in the kit, and make sure there's a consistent API, and it makes the workflow a lot easier. So here is our workflow in a nutshell. First, it starts off with the design system. And then from there, the engineers create a theme file. And that file will include like colors and font sizes and padding. That way you can use it within any of your apps. And this is also a great time where the designers are using Sketch to create their masterpieces. And then they send them over to Zeppelin. And engineers can then use those files to create things in Storybook. From Storybook, a PR is made, and a link is shared with the design team. Then the component goes through a visual QA, and if the component doesn't pass, it goes back, the design team makes a JIRA ticket, and it goes back to Storybook. And that's a huge feedback loop, and it's a lot of work, especially when something wasn't voidable. So we came up with the idea of pairing with designers. If you didn't tell, there's a lot less arrows now. There's only 1 versus 4. But our designers have this thing where they go, we are here if you need us. And it's really great because there's this thing called open offices. So it's a great way to contribute, use a space. And pairing can range between 5 to 30 minutes, depending on the engineer's need or what the ticket entails on the design and UX front. We found this to be a huge improvement into the workflow. So we got rid of that nasty feedback loop with the designers, and then it goes to a QA team who does all their QA in Storybook. And last but not least, we have a component in a component kit. And that's it. Thank you, guys.